Welcome to MAT 2LB booklet number 7, Geometry, lesson number 6, More Complex Areas. So today's lesson is sort of an extension of lesson number 4 and 5, where we were talking about areas of rectangles and triangles and the area of circles. Today we're talking about more complex areas, which for us means starting to examine, if you see it up here in this top piece, it's called composite shapes. And composite shapes are basically combinations of two or more shapes into one new sort of super shape that combines the characteristics of rectangles, triangles, and circles in one kind of weird lumpy new shape. The strategy for us is to, when we're dealing with a composite shape, is to try to break it down into its component pieces before we do those calculations. So let's start by looking at example number 1. Find the area of the following composite shape. So here we have something that sort of looks like an arrow kind of pointing off to the right. Now there are two different familiar shapes inside here, and I'll sketch them with my highlighter. First one we have here is sort of like a rectangle, and the second shape that makes up our composite shape is sort of like a triangle right there on the tip. So in order for us to calculate the composite area, or the area of this entire shape, we need to calculate the area of those two pieces, the rectangle and the triangle. And that's going to require us to think back 2 lessons to the formulas that we were using back then. So let's get the first one here started. I'll do this one in orange to sort of match up. So this one over here, we're talking about the area of a rectangle. And in order to do that, we need to know the length and the width of that rectangle. So the length of this particular rectangle, now you'll notice you'll be tempted to look up here at the 19, but please don't be distracted by the 19. The 19 is actually all the way from the bottom of that rectangle to the top of the triangle. That's not the one we want. The one we want is just the side of the rectangle, and that's actually going to be 13 right there. So the length of our rectangle is going to be 13 inches, leaving the width, the perpendicular side, to be 8. Now we can make this calculation. So the area will be equal to the length times the width, and we are going to have, for this rectangle, 13 times 8. And now let's put that into our calculator and see what we get. So 13 times 8 gives us 104 inches squared when we're talking about area. All right, that first piece was pretty successful. Now, the triangle will be a little bit more challenging. The first step isn't so bad, because if we want to consider the base of our triangle, so I'm going to just sort of take that shape and I'm just going to sketch it off to the side, imagining we sort of flipped it around. So imagine you've taken this shape and we sort of have drawn it in this configuration here. I've sort of twisted it around. The base of our triangle is actually going to be the same as this side of our rectangle. Can you see how they're lined up? They're actually parallel. So the base of our triangle, which is one of the 2 variables that we need, is going to be 8. Now the piece that we're missing is the height. We're missing the height. That's the piece that's going to be perpendicular to the base. And we don't have that one yet, but there's a way that we can figure it out. And the way that we can figure it out is to consider that, and I'm going to grab a new color here, consider that this whole distance is going to be 19 inches. And we just want this little piece right here. The way to figure this out is to take 19, which is the total distance, and subtract this little piece here that we know. And this little piece here that we know is 13. So for us to figure this out, we can say here that our height is going to be equal to the full length minus that little piece that we do know, which is 13, giving us a height of 6. So there's our 2 variables. We have a height of 6 and a base of 8. Now we can start using our formula. The area of our triangle will be base times height divided by 2. For this triangle, that will be 8 times 6 divided by 2. That will give us an area equal to, so let's type that into our calculator. 8 times 6 divided by 2 gives us an area of 24, and our unit of measure is inches squared. So now what we've done is we've calculated the area of our 2 shapes all by themselves. Now we just have to combine them. So I'm going to do that in a new color. I'm going to take these 2 here, I'm going to add them together. So the total area will be equal to the area of our rectangle, which was 104, added to the area of our triangle, which was 24. And those line up so nicely. Let's just do some quick vertical addition here. So 4 plus 4 will give me 8, 0 plus 2 will give me 2, and 1 plus 0 will give me 1, and can't forget my unit of measure. So my total area will be 128 inches squared. So fair number of steps here. We have to be a little bit flexible in the way that we think about it. But in terms of our procedure, we want to take our composite shape and break it into 2 pieces, or as many pieces as we need to, find their respective areas, and then add them together at the end. So that's going to be our strategy. Let's have a look here at example B. We'll do this one here together. What I'd like you to do is see if you can figure out what 2 shapes we have here. I'm going to ask you to hit pause. When you think you know the 2 shapes, come on back and we'll see how you did. Okay, our 2 shapes are going to be, like last time, the rectangle. So we have the rectangle here in common, but we also have this interesting sort of half circle thing happening here as well. So half circle. We need to consider both of these. So let's start with the more straightforward of the 2, which I think is going to be the rectangle. So let's figure out the area of the rectangle. We need to know the length and the width. So the length of our rectangle will be 12. The width of our rectangle will be 8. That allows us to calculate the area. So the area equals the length times the width. And this rectangle will be 12 times 8. And that area will be equal to, when we ask our calculator, 12 times 8, we get 96 feet squared. So that one, the more straightforward of the 2. Let's have a look at this circle. Now it doesn't seem that we have any pieces of information about this circle yet. And that's true. None were provided explicitly, but we do know that the distance all the way across, so this piece right here, if you can see me drawing it, that piece all the way across the circle, that's a diameter. And because it's parallel to this right here at the bottom, we know that the diameter is going to be 8 feet. So we know the diameter is going to be equal to 8 feet, but what we need is the radius. So the radius will be equal to, if you remember, half of our diameter. So the radius of this circle is actually going to be 4 feet. The last variable that we need is going to be pi. Pi is always going to be 3.14, and now we can start using our formula. So our formula is the area equals pi times the radius squared. So the area will equal 3.14 times 4 squared. Let's type that into our calculator and see what we get. 3.14 times 4 squared gives us 50.24, and again these are going to be in feet squared. Now before we move on, that's the area of a full circle, but you'll notice in the picture we actually only have half a circle there. So what I need to do is take this total and divide it by 2 to get the actual area of that half circle. So I take my 50.24 and I divide it by 2. That's going to give me 25.12 feet squared for the actual area in the picture. Alright, so now we've calculated the area of our 2 portions of this composite shape. Now we need to bring it all together to come up with the total area. So the total area, and again we'll write these down. So there's the area of our rectangle. It's going to be 96.00. The area of our semicircle is 25.12. Again, this sets itself up so nicely. Let's do some vertical addition. 0 plus 2 is 2, 0 plus 1 is 1, 6 plus 5 is 11. I'm going to carry that 1. 1 plus 9 is 10, and there 1 plus 9 is 10 plus another 2 is going to be 12. So we have 121.12 and our unit of measure feet squared. So these are a little bit challenging for sure. When you head off to the worksheet, you're going to see examples that are similar in that they're made up of composite shapes with familiar pieces, but each one's going to be a little bit unique. So hang in there, show some grit when you're done going over this lesson. Good luck with the worksheet, and I'll see you in lesson number 7.